I am Bhagilakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the Initial Value Theorem and Final Value Theorem. We are going to verify this term, and this belongs to the unit Laplace Transforms. So first, what is the statement? So initial value theorem, if the Laplace transform of f of t and f dash of t exists and L of f of t equal to f of s, then limit t tends to 0, L of f of t which is equal to limit s tends to infinity s into f of s. So these two conditions we want to check it now. So the first condition is the left hand side t tends to 0 is equal to the function with respect to t is equal to the function with respect to s. Here s tends to infinity. So initial means here initial value use. If it is a final value theorem means the same statement with this. So the final statement t tends to infinity will come. At that time s tends to 0. So this is a difference between the initial value theorem and final value theorem. So these concepts only we are going to check it now. So based on this we can go for the on basic example sum. So the first sum is verify the initial and final value theorem for f of t equal to 1 plus e power minus t sin t plus cos t. So this is a basic sum we can choose. So in this given f of t value is given, first the left hand side right side based on to check the function we need s into f of s value. So first I am calculating f of s. F of s is nothing but L of f of t. So L of f of t means here we can replace the f of t value. So take Laplace to each and every term. So first term L of 1 and then second term here already we multiplied e power minus t with the first term and e power minus t with the second term. We separated these as two terms and then each and everything is separated. Then we go for the Laplace. So first term L of 1 plus L of e power minus t into sin t plus second term is over. Next third term e power minus t into cos t. These three terms are separated. Next we go for the applying formula. So L of 1 is nothing but 1 by s, and here first e power minus at into sin f of t. So in this L of you can replace by this e power minus t as s tends to s plus 1, and this L of f of t we can take it. We can write like this using first shifting theorem. Same thing e power minus at into cos t. So this one also we can write as s tends to s plus 1 and L of f of t. So after this L of sin t formula I write here. So 1 by s square plus 1 into here s tends to s plus 1 plus L of cos t is s tends to s divided by s square plus 1 and s tends to 1 s plus 1. So after this the formula is over. So all the Laplace transforms are over. So now we can replace s by s plus 1. So instead of s we can replace by s plus 1 plus 1, and also here also s square plus 1 in the denominator. In the numerator also we are having s in the second term. So there also we can replace by s plus 1 and the denominator s square. Instead of s plus 1 the whole square we can replace. So after this we can go for the simplification part. So in this the second term based on these two we are having the common LCM. So expanding s plus a plus b the whole square term, and with the plus 1 we got the s square plus 2s plus 2, and in the numerator s plus 1 by common LCM means we can add the numerator. So s plus 1 plus 1 is s plus 2. So this is the term we got, and also we need s into f of s value. So multiply s by both sides and we got the answer. Now based on this value we can go for the condition verification of the initial and final value theorems. So the first work is initial value theorem. So initial value theorem is the limit t tends to 0 f of t and which is equal to limit s tends to infinity s into f of s. So for the function f of t apply t tends to 0. So this is function f of t. We are applying t tends to 0. So here t tends to 0 means e power 0 1 and sin 0 0 cos 0 1. So here 1 plus 1. So which is equal to 2. So the left hand side value we got it as 2. Next we can check it for the right side value. So already we know s into f of s value. So s into f of s, instead of s we need to apply infinity. So whenever you are applying infinity, take that common term. So if it is in the denominator, we can apply the limit infinity means 1 by infinity, which is equal to 0. Otherwise it is the total term is equal to infinity, you will get, that is indeterminate form only you will get. So here combining these two and multiply this s, and after this we got this condition. So s square plus 2s, you take it as a common term, the remaining you will get 1 plus 2 divided by s square plus 2s. So after this we can cancel this numerator denominator, and also in this we got the condition 1 plus 2 divided by s square plus 2s. So after this apply the limit. So 1 plus, for this condition applying the limit s tends to infinity, we got the 1 divided by z, that value which is equal to 1. Then 1 plus 1 which is equal to 2. So we got the left hand side and right side both the terms which is equal to z 2. So initial value theorem is verified. Next we go for the final value theorem. So final value theorem is nothing but the t tends to infinity into f of t, which is equal to limit s tends to 0 s into f of s. So first we can apply for this function f of t with the limit of t tends to infinity. So e power minus infinity which is equal to 0. So 0 into any value which is equal to 0. So you will get this 1 alone. So the value of left hand side is 1. So same thing we can check it now. So s into f of s, here s tends to 0. So first to multiply this s to the first term. So you will get 1 plus s into s squared, whatever it is, with the s term you will get. So 1 plus 0 only you will get. Instead of s, if you replace by 0, you will get 0. So the final answer is 1. So from this we got left hand side as well as in the right side which is equal to 1. So the final value theorem also verified. So this way we can verify that initial value and final value theorems. Thank you.